This video is going to look at how we add and subtract complex numbers. And to start off, I want to look at a complex number. Again, I said is a number that's made up a real part and an imaginary part. For an example, if we have A is going to represent our real part plus BI is going to represent the imaginary. So here A is the real part and B is going to represent the imaginary part. And the way we would write a number in standard form, this here is the standard form. So if you have the direction that says write the number in standard form, again, your real part and then plus or minus bi, which is the imaginary. So I could give you an example of, say, the number 2 plus 3i. And here, 2 is the real part and 3 is representing the imaginary part. And if we want to actually plot a complex number, we're going to look at, instead of having the x and y axis, the what we think of the horizontal or the x axis is going to be the real axis and the y axis is the imaginary axis. So if we were going to plot the number 2 plus 3i, the real part would be over 2 to the right and then 3 up on the imaginary axis. So this point would be located here. So you're going to plot it very similar to just plotting an XY coordinate, except for 2 is the imaginary, I'm sorry, 2 is the real and 3 is the imaginary. So for example, if we had the number, let's say, negative 1 minus, let's say, 4i, then that means that you would go 1 to the left and then down 4 units. And that point would be here. All right, if we have an example here of simplifying a number, and we want to take this number here, 5 plus the square root of a negative 36. We want to write this in standard form. So the only way we can simplify this, of course, 5 is the real part. And if we take the square root of a negative 36, we know the square root of 36 is 6. And then we have the negative, so that's going to come out as an I. So this is equal to 6i. And again, this is our standard form where we have a plus bi. So that's how we would write this. 5 plus 6i would be the complex number in standard form. Now, if I was to give you, say, a negative 2 plus 8i is equal to a plus bi. If this is the case, what is a and what is b? Well, if these two numbers are equal, then that tells us that a must be equal to a negative 2 because that's the real part, and b has to be equal to 8 because that is the imaginary part. So here a is a negative 2, b is a positive 8. Now if I was to have, let's say, a plus 6 plus 2bi is equal to 6 minus 5i. So now the question is, what is a and b if this quantity is equal to 6 minus 5i? Well, to solve for a and b, we know that here the real part, a plus 6, has to be equal to 6. So we would say a plus 6 is equal to 6. And if we solve for a, we would subtract 6. So therefore, a is equal to 0. And then the imaginary part, 2b, has to be equal to a negative 5. So we would take 2b equals a negative 5. So therefore, divide by 2, b is equal to a negative 5 halves. So a would have to be equal to 0, and b is equal to negative 5 halves if these two quantities are going to be equal. All right, so now let's actually look at how would we add two complex numbers. If we had the first number is 13 minus 2i plus a negative 5 plus 6i. If we're going to add these two complex numbers together, notice we have parentheses, and really we can think of dropping out the parentheses. They're not necessarily needed here. We could write this as 13 minus 2i minus 5 plus 6i. Now you could leave it with the parentheses and realize that you're just going to simply add the real parts together and you're going to add the imaginary parts. I typically prefer to rewrite this without the parentheses and just think of this as you would with any algebraic expression. In other words, we're just going to simply combine your like terms. Well, we have a 13 and a negative 5, so 13 minus 5, we would end up with 8, and then we would take a negative 2i and a positive 6i, and that's going to be equal to 4i. So there we have our complex number, a plus bi, 8 plus 4i. So really it's that easy. Adding complex numbers, you're just basically going to combine your like terms. So again here, we're simply adding your real parts together and you're adding your imaginary parts together. So let's look at another example. Let's say that we have a negative 4i squared plus 2i. And we want to write this as a complex number in standard form. So how do we start to simplify this? Well, the first thing should be somewhat obvious. We have I squared, so we could write this as negative 4 times I squared, and the I squared reduces to a negative 1 plus 2i. Now again, I, we cannot reduce that any further. So we have a negative 4 times negative 1 is positive 4 plus 2i. So there's our standard form. All right, so there's some examples of addition. Let's look at a couple examples of subtracting a complex number. Now I'm going to take the same 2 that we had before, 13 minus 2i. Now instead of adding, we're going to subtract them, a negative 5 plus 6i. And once again, you could, just subtract the real parts and subtract the imaginary, but I like to eliminate the parentheses. So we would simply have 13 minus 2i. And here we're going to distribute the negative sign. So a negative negative makes it a positive 5, and a negative and a positive makes it a negative 6i. So at this point, we're simply going to combine our like terms. So now we would have 13 plus 5, which is 18, and a negative 2i and a negative 6i, which is a negative 8i. And at this point, you have your real part is 18, your imaginary is a negative 8, so this is our standard form. All right, one last example. We have 8 plus the square root of a negative 18 minus 4 plus 3i square root of 2. So now the first thing you want to do here, anytime you have a problem with a square root, you want to simplify the square root first. So I'm going to go ahead and drop out the parentheses and simplify the square root of a negative 18. So here we could think of this as the square root of a negative 1. And the 18 is not a perfect square, but we can write that as 2 times 9 because 9 is a perfect square. And if I distribute the negative sign here, we would have a negative 4 minus 3i square root of 2. So now if we go back, we can simplify the square root. We know the square root of 9 is 3. The square root of a negative 1 is I. And then we would simply leave the square root of 2 because we cannot pull out the 2 from underneath the square root. And then we have minus 4 minus 3i square root of 2. And here we can once again combine the real part. 8 and negative 4 is 4. And we'll notice here that we have our imaginary part. One's positive, one's negative. So the 3i squared of 2, they're going to cancel each other out. So therefore, our answer is simply 4. So here what happens is the imaginary part disappears, so your answer is simply a real number. I guess technically you could think of this, your answer would be something like plus 0i, but your answer is just a real part.